90 billion US dollars is the revenue generated annually by the endless grasslands of Australia. This agricultural superpower feeds global markets with a constant stream of produce. One can notice the sheer scale of the operations stretching across the continent, but this is just the beginning. At first glance, the land seems inexhaustible, but in reality, it is deteriorating faster than ever before. Why does the nation's economic standing begin to tremble? The crisis has deep and spreading roots. After decades of intense farming, the Australian soil has lost more than 60% of its vital organic matter. 4 million hectares fall into severe degradation each year, rendering vast areas unusable. Dust clouds rise from the dry earth as the ground structure collapses. In desperation, the country chased every possible solution to save the soil. Yet all conventional attempts failed to halt the damage. Transition to the next level. Scientists finally discovered a clue hidden in piles of leftover sheep wool. This waste product became the unexpected tool to turn the tide in the driest nation on Earth. 427 million hectares. Exactly this amount of agricultural land covers the vast territory of Australia. For decades, this region served as the unshakable symbol of prosperity for the Southern Hemisphere, where livestock feed global markets and fields stretch to the horizon. However, beneath the visible layer of greenery, a critical transformation is taking place. The land is deteriorating at a speed that forces local experts to sound the alarm. Why do these apparently fertile zones face the threat of total biological exhaustion? At first glance, the landscape remains unchanged, but in reality, the soil is losing its chemical foundation. In New South Wales, once the heart of national agriculture, organic carbon levels dropped by an additional 3.1% between 2006 and 2020. This significant decline occurred in a span of just 14 years. Consequently, the Earth loses its physical ability to retain water and supply nutrients to the microorganisms that crops depend on. One can notice how the ground becomes brittle and lifeless, failing to support plant growth. But this is just the beginning of the ecological shift. In harsher regions like Western Australia, the wind carries away the soil itself, effectively stripping the farming industry bare. The wind removes up to 1.8 tons of fertile material per hectare annually through erosion. One can observe how a layer that takes nature hundreds of years to form vanishes completely after only a few strong gusts. It is visible how the fields turn a dry, burnt red, taking on the characteristic color of desertification. More than 6 million hectares are already classified as being at extremely high risk of erosion. Another 3,200,000 hectares are physically collapsing due to degradation caused by water. In Queensland, many farming households have no choice but to abandon plots that fed families for generations. The soil structure has crumbled so severely that it can no longer hold enough moisture to sustain a single growing season. Thus, the continent faces a crisis that reshapes its agricultural future. 4 billion United States dollars. This was the staggering export value generated annually by the merino sheep trade at its peak. Australia was once the world's wool kingdom, but land is not the only thing falling into crisis alongside the exhaustion of the soil to sustain a growing season. Why has this industry, once a national symbol, struggled so intensely? At first glance, the agricultural infrastructure remains in place, but global demand has declined over the past 2 decades, damaging the sector's foundation. Consequently, factories have shut down while raw wool prices have plummeted. Thousands of farming households are left without enough profit to maintain their flocks. For the 2024 to 2025 period alone, national wool production is forecast to drop to just 279 million kilograms. This volume is more than 12% lower than the previous year. But this is just the beginning of the problem. one can notice how an estimated 200,000 tons of waste wool accumulate on farms each year. The material piles up, unwanted, unsellable, and almost useless. It seems like simple organic matter, but in reality, if left to decompose outdoors, wool can take 3 to 5 years to fully break down. Because disposal is expensive, this creates a significant burden for farmers. The excess material simply waits for a solution on the land. 3 to 5 years is the time required for dense mats of discarded wool to fully break down under natural environmental conditions. Why did Australian researchers turn their attention to these seemingly useless piles of fibrous waste? At first glance, the material appears to be nothing more than a troublesome byproduct of the shearing industry that clogs up landfills. But laboratory analysis revealed that the microscopic architecture of wool fibers possesses an almost perfect structure for regenerating depleted agricultural earth. Each individual strand contains keratin scales capable of holding 1.5 to 2 times their dry weight in water. Simultaneously, the fibers create networks of tiny air pockets that allow oxygen to seep deep into the compacted ground, providing an element that Australia's depleted soils lack desperately. But this is just the beginning. Confirmation came immediately from real-world tests as science moved from the lab to the field. In early trials across the parched regions of New South Wales, engineers spread a layer of wool just a few centimeters thick over the degraded surface. One can notice how the landscape changes under this protective beige blanket. Surface evaporation drops by up to 35% compared to uncovered ground, preserving critical resources. Soil moisture remains stable for nearly twice as long as with conventional organic mulch, defying the arid climate. It gets more complex further on. Microbial density, which had declined severely after years of intensive mechanical cultivation, increases by 30 to 50% after only a few months. This kick-starts a new cycle of biological recovery, where organic matter forms faster and crops begin to regain a secure foothold. On abandoned fields in Queensland, where farmers previously watched in despair as the earth cracked open from its inability to retain a single drop of water, the texture transforms. At first glance, it seems impossible for a simple surface layer to stop desertification, but in reality, the experimental wool mulch created a critical difference. The land ceases to be brittle red dust and becomes friable, grippable soil ready for planting. And this is not the limit. However, the raw material cannot simply be dumped onto the fields without preparation. Unprocessed fibers naturally tend to clump into thick, impermeable mats that decompose very slowly and make it difficult for water to permeate the soil. To unlock the full potential of this resource, it must be treated properly through mechanical and biological means. This is exactly why engineers created wool pellets and specialized wool compost. Pellets are a refined form of waste wool, ground up and compressed into small granules that can be mixed directly into the earth. Everything only gets more complicated. Thanks to the keratin structure that expands and contracts with moisture, each pellet functions like a biological water battery. It absorbs liquid when the soil is wet, stores it deep inside the fiber matrix, and gradually releases it as the surrounding earth begins to dry. One can see how the granules swell, holding the water until the roots demand it. This mechanism helps the soil retain moisture 25 to 40% longer, significantly easing irrigation pressure in hot, arid environments. Transition to the next level. While wool pellets address the problem of moisture retention, wool compost plays the role of long-term soil nourishment. When sheep wool is composted together with microorganisms and organic matter, the keratin breaks down slowly over time. This releases a steady source of nutrients, including nitrogen, sulfur, organic carbon, and trace minerals directly to the plants. As a result, soil microbial density increases again, by 30 to 50%, creating conditions for the ecosystem to regenerate on its own. One can notice how the compost improves soil looseness and heat retention capacity, helping the fields withstand prolonged heat waves. In many test regions, adding this biological compost has helped increase crop yields by 12 to 18% without requiring additional chemical fertilizers. The transformation of agricultural waste into a vital resource completes its cycle. 900 kilograms of dense wool pellets are produced from every single ton of waste wool processed in workshops. This high yield transforms material that once cost money to dispose of into raw resources that every factory now wants. The wool industry, previously mired in a deep crisis, suddenly rebounds in a way no one anticipated. But this is just the beginning. Why has this specific recycling sector exploded so rapidly in rural regions? At first glance, it seems like a minor agricultural adjustment, but the implications are vast. The resulting processed material revitalizes soil without requiring additional chemical fertilizers, driving intense market demand. In the year 2024 alone, the state of Victoria saw more than 40 wool recycling startups emerge. One can notice how the compressed material forms a product worth 3 times more than the original raw wool. Around 2,500 new jobs have been created to support this processing chain. It does not end at this stage. Something once considered absolute waste has now transformed into a product line worth millions of dollars. This cycle sustains an entire new business ecosystem. Moving forward without waste, 25 million sheep graze across New Zealand, representing a vast resource just across the strait from Australia. This country has also recognized the potential of wool beyond textiles, and results are emerging faster than many expected. On coastal farms, sandy soils are typically dry, compacted, and poor at retaining water. Why is mixing in wool mulch so effective here? It might seem that the sand would simply swallow the fibers without effect, but this addition allows the soil to maintain moisture 20 to 30% longer. One can notice how the ground texture changes as the material integrates into the earth. On the basalt fields of the North Island, the impact is biological. At first glance, the land remains silent after application, but in reality, researchers have recorded the return of soil microorganisms just a few months after incorporating wool. This serves as the first sign that the land is beginning to breathe again. These positive signals quickly inspired the Kiwi business community to innovate. In Wellington, the startup Woolkeem developed a technology that turns waste wool into biopolymer granules. It is visible how the equipment produces uniform pellets with remarkable water-holding capacity. This opens up an entirely new application avenue. But this is just the beginning. In Marlborough, the country's famous wine region, farmers use wool as a ground cover between the vines. Therefore, this method has reduced irrigation needs by up to 25% during prolonged dry months. For New Zealanders, wool was once merely a textile material. Now, it is becoming a key to sustainable agriculture, much like what is happening in Australia. The transition to these new farming methods continues steadily. A fraction of the size defines the United States sheep industry compared to the massive scale in Australia or New Zealand. Why does wool play a completely different role here? At first glance, the material seems to serve the same purpose everywhere. But in reality, the issue is not an excess of raw material, but the urgent needs of the farmers themselves. They strive to farm organically, yet lack stable natural nutrient sources to replace chemical fertilizers. It is in this gap that wool takes on an unexpected role as an organic fertilizer. But this is just the beginning. One can notice how farmers in California, Colorado, and Vermont incorporate compressed wool pellets into the soil structure. They do this not to address drought as in Australia, but to create a slow-release nitrogen source that organic crops typically lack. Something surprising happened after 2 months of monitoring the fields. Soil analyses showed 15 to 22% less nitrogen leaching into the groundwater. Simultaneously, moisture levels stayed stable 18 to 25% longer compared with control fields. It gets more complex further on. Thus, wool does not just improve the soil, but helps protect the credibility of an entire agricultural sector. In an environment where every fertilizer must prove its origin, pellets satisfy all criteria of purity and sustainability. It is no surprise they have become a new label of organic agriculture. Farms in California even print "grown with wool pellets" on packaging as a visible promise of transparency. Hundreds of hectares of solar fields stretch across the plains of Texas, forming a vast grid of glass and steel. This scale marks the next chapter in agriculture, where the story moves beyond wool fertilizers to entirely new ecological models. The most striking of these concepts is solar grazing, where sheep take over the role of heavy machinery. Operators previously faced the expensive task of mowing grass beneath thousands of panels, navigating around fragile equipment with difficulty. But this is just the beginning. Why would high-tech energy giants turn to livestock for maintenance? It seems like a step backward to mix advanced photovoltaics with grazing herds. However, mechanical mowers pose a constant threat to ground wiring and panel frames, while often failing to reach tight spaces. Sheep, by contrast, clear low-growing vegetation with precision without causing any structural damage. One can notice how the flock moves methodically through the rows, seeking the shade that helps the soil retain vital moisture. Their manure adds natural nutrients to the ground, allowing grasses and soil microorganisms to recover naturally. At first glance, this biological approach seems like a minor adjustment, but in reality, it fundamentally alters the economics of energy production. Many farms report reducing the use of chemical fertilizers by up to 70%. Furthermore, overall maintenance costs drop by half compared with traditional mechanical mowing. The process is only gaining momentum. The United States energy sector is now partnering directly with sheep farmers, a collaboration that was rare in the past. Flocks once raised strictly for wool or meat have transformed into ecological maintenance workers. They reduce carbon dioxide emissions and restore soils simply by following their natural grazing instincts. In states such as Colorado and California, monitoring reveals that sheep grazing solar fields restores vegetation 2 to 3 times faster than conventional solar projects. From this data, a mutually beneficial model has taken shape where farmers gain extra income and energy companies reduce operating costs. It is visible how the semi-arid desert ecosystem slowly revives right beneath the shimmering panels. Agriculture, energy, and the environment unexpectedly merge into a single system. And this is not the limit. The number of solar grazing projects across the United States has tripled in just a few years, outpacing initial expectations. This rapid expansion has given rise to an entirely new service industry known as professional grazing crews. These teams do more than simply transport sheep to the site to eat grass. They actively advise engineers on designing solar farms to suit sheep movement patterns, calculate vegetation density with scientific accuracy, and account for breeding seasons. Specialists create weekly schedules for ecological maintenance, completing the integration of nature and technology. Miles of fertile territory disappear annually as the Sahara Desert relentlessly expands across the Sahel. The results demonstrated by sheep wool act as more than just a success story for Australia. They serve as a warning signal for a planet that is gradually drying out. One can notice how unprotected soil turns to dust under the sun. But this is just the beginning. The implications extend globally. Why turn to a material previously considered biological waste for such a massive task? At first glance, the organic fiber seems too simple to combat severe desertification. However, this mechanism allows the ground to retain vital moisture without the installation of billion-dollar irrigation systems. Regions like the Middle East are historically even drier than the arid landscapes of Arizona. This trajectory confirms that the technology belongs to more than just New Zealand or the United States. It demonstrates that solutions to the biggest planetary challenges often emerge from the smallest materials. The wool strand completes its function, offering a renewed cycle for the Earth.